Hi everyone, and welcome to this grade 9 mathematics lesson where we will be exploring perimeter of composite shapes. My name is Miss Donnell Phillips. Let's get started. So I don't know if you guys could remember, but when we were much younger, probably in Prep A or Prep B, and the teacher would ask us to draw our house, we would usually draw something looking like this. We would start off with a triangle, and then we would finish off with a rectangle, probably for the base of the house, and then we would put in two other smaller rectangles that would represent the poles. Now, this, what we used to do here, is considered a composite shape. Now, just by looking at this diagram, do you think you would be able to give me a definition for a composite shape? Alright, so we're going to be exploring how we calculate the perimeter of composite shapes. But before we actually get to the calculations, we're going to define what a composite shape is. So what is a composite shape? A shape that can be divided into more than one of the basic shapes is said to be a composite shape. So the basic shapes that we know are triangle, square, rectangle, and circles. So if we look at a shape and we could see that it has more than two of the basic shapes, then that shape is called a composite shape. In these two examples, in the first one we have a rectangle and a semicircle coming together to form a new shape. And in the other one we have a square and a triangle coming together to form a new shape. So these two are examples of composite shapes. Now, in order for us to find the perimeter of a composite shape, we need to follow three simple rules. The first one is to make sure every side length is labeled with a length. Number two, to find missing lengths, use the properties of the composite shape in order to find the side lengths. And thirdly, total the side lengths. So all this is saying is that if we have a composite shape to find the perimeter, the first thing we should ensure is that all of the sides are labeled with a side length. If the sides don't have side lengths, then we have to use the properties of that specific shape to come up with the missing side lengths in order for us to move on to the third step, which requires us to just add all of the side lengths. So if we look at these two examples here, in the first one we have a rectangle and a semicircle. We would have to use the properties of the rectangle to label all of the sides if there are any missing. And we know that in a rectangle, the opposite sides are always equal. So let us say we were given a length for at the bottom and not a length for at the top. We know that whatever is the bottom would also be at the top, because in a rectangle, the opposite sides are always equal. First example. If we look at this shape, we could see that it could be divided into two different rectangles. We have a horizontal rectangle and a vertical rectangle. So, in this example, all of the sides are given. So we would actually skip the second step and just proceed to adding all of the sides that we are given. So we start from the top. We have 3 cm, 8 cm, 10 cm, 4 cm, 7 cm, and another 4 cm. And when we sum them, we get that the total is 36 centimeters. So that means that the perimeter of this composite shape is 36 centimeters. We have two other examples, but in these examples, some of the sides are missing. So we would have to use step number 2, which requires us to use the properties of each individual shape to find the missing sides. Next example, we have a shape that looks like this. Here is labeled 4 cm. On this side we have 5 cm. On this side we have 8 cm. And then at the top we have 3 cm. So the first rule is to ensure that all of the sides are given lengths, but we recognize that these two sides are missing. So what we need to do is use the properties of the shapes. You could either use the properties of rectangles, and in this case that is what we're going to use, to put lengths to these sides. So let me just bring this across here so you could see. Now let's look at this shape here. We know that this is a rectangle, and one of the properties of a rectangle is that the opposite sides are always equal. That means that if this length here is 5 cm, this length here should also be 5 cm. But we're given it's broken there, and this length here is actually 3 cm based on this length there. So it means that in order for us to be able to know what this length here is, we need to subtract it from 5. So 5 take 3 gives us 2. So this length is 2 cm. If we add them back, we're going to get 5. This is equal to 5. 2 plus 3 is also equal to 5. Now let's focus on this length here, this rectangle here, sorry. If we bring this down, we can see that this also is a rectangle. This length is 8 cm. It means that this length here should also be 8 cm. But we only know that this portion here is equal to 4 cm. So if this portion here is equal to 4 cm, then this remaining portion there is also equal to 4 cm. So now that we have all of the side lengths at the top, 3 cm, on this side 8 cm, at the bottom 5 cm, on this side 4 cm, 2 cm and another 4 cm, then we could proceed to summing them. So we would have to add 3 plus 8 plus 5 plus 4 plus 2 plus 4. And all of this would still be in centimeters because that's the unit. So when we sum all of these lengths together, we find that it is equal to 26 centimeters. So that means that the perimeter of this composite shape is equal to 26 centimeters. In the next example, we have a shape that looks like the outline of an ice cream cone. Here is equal to 1 inch. Then we have another inch here and another inch there. In order for us to calculate the perimeter of this shape, we need to be able to find this missing side. And this shape at the top here is actually a semicircle. So in order for us to know what this circumference is, we have to calculate the circumference of a circle and divide it by 2 because it is a semicircle. So we're going to go ahead, we're going to use the formula. Since we're given the diameter of this circle, we have to use the formula that states circumference is equal to pi d. So the circumference is equal to pi, and we're using pi as 22 over 7 times the diameter, and the diameter here is 1. And we know that when we multiply anything by 1, we will just get back the answer. We will just get back. And we know when we multiply anything by 1, we will just get back the number itself. So in this case, 22 over 7 multiplied by 1 would give us 22 over 7. So because this 22 over 7 would actually represent the entire circle, and we just want half of the circle, we have to take this 22 over 7 and divide it by 2. So 22 over 7 divided by 2 over 1. When we're dividing fractions, we rewrite the first one. We change the division sign to a multiplication sign, and we upturn the second one. So this would be 1 over 2. So now we have 22 over 7 multiplied by 1 over 2. And we could reduce this. 2 into 2, 1. 2 into 22, 11. So 22 over 7 divided by 2 is equal to 11 over 7 cm. So 11 over 7 cm represents this missing side here, which is half of the circumference of this circle. So now that we have this missing side here as 11 over 7, so when we divide 22 over 7 by 2, we get 11 over 7. So that means that the circumference of this semicircle is equal to 11 over 7 inches. So we can just put it in here, 11 over 7. So now that we have side lengths for this entire figure here, all we have to do now is add them. So we have to add 11 over 7 plus 1, which is this side, plus 1. So this is just going to be 11 over 7 plus 2. We could write this 2 over 1. Whenever we're adding or subtracting fractions and the denominators are not the same, the first thing we have to do is find the LCM of the two denominators. And the LCM of 7 and 1 would be 7. So 7 into 7, 1, we multiply this by 1. And 1 into 7, 7, so we multiply this by 7. So 11 times 1, 11, plus 2 times 7 is 14. When we add them, 11 plus 14 gives us 25 over 7. And we can break this down. We don't need to leave this as an improper fraction. How many times could 7 go into 25? 3 times, because 3 times 7 is 21, and we have 4 remaining, so we write that as the numerator, and the denominator remains the same. So this gives us 3 and 4 over 7 inches. So the perimeter of this composite shape that consisted of a triangle and a semicircle is 3 and 4 over 7 inches. So to summarize this lesson, a composite shape is a shape that consists of more than one basic shape. And to calculate the perimeter of a composite shape, make sure every side length is labeled with a length, then total its sides. So for your homework, you're going to calculate the perimeter of these two composite shapes. In the first shape, you can see that it consists of a square, a triangle, and a part of a circle. And in the second shape, we have rectangles and a triangle. I do hope that I was able to shed some light on how we calculate the perimeter of composite shapes. Join me again next time. My name is Miss Donnell Phillips. Take care.